So here we are asked to find the domain and range for a function, an equation given now f of x equals 2x cubed minus x. So here knowing the shape of the graph helps you to at least visualize of where your input values are defined and what kind of output you will be getting. So right here, I know that a cubic function has somehow a shape that either looks like this or a shape that either looks like this. Knowing the leading term, the coefficient of the leading term, if it's positive and negative, identifies what kind of shape the graph has. However, both ways they have this shape. And notice right here, if I were to look at this function is identified on every value of x. So meaning I can input any value of x, not excluding any of it, and I would be able to get an output. So here I can put a negative number and I can get an output. I can put a 0 and I can get an output. I can put a positive number and I can get an output. So here I would say that my domain is all real numbers. In interval notation, I would write it from negative infinity to infinity. And the fact that I would be able to get an output for every input, and here my range would also be defined from negative infinity to infinity. The cubic function is identified, the domain is all real numbers, and the range is all real numbers. However, not every function is identified the same way. So for example, if I have f of x is equal to x squared plus 2. Notice that this is a parabola. Since the highest power is a 2, then we have a parabola. And we know that a parabola, for the domain, it's all real numbers, so I can input any real number for my domain, meaning my domain is from negative infinity to infinity. So here we have the shape of the toolkit function of a parabola, where we know that it starts at 0, 0. So now here we have x squared plus 2, meaning that my parabola is going to go up 2 units. However, it's still a parabola, meaning my domain is identified from negative infinity to infinity. However, now my range, notice that, let's erase this parabola. Notice that my range right here, it's not identified everywhere. So if I were to walk on my x-axis, notice that the first number I hit on the x-axis is 2. And then going on forward, it's identified everywhere else. So then here, my range is from 2. I include the 2 because for some input, if I input a 0, f of 0, 0 squared plus 2, my output would be 2. So 2 is defined in the function, so I put a bracket. So it's from 2 to infinity for my range. So for this function, I'm asked to also find the domain and range. So now first, let's look at this function. Notice that the shape of this function looks like a rational, meaning that it looks like a fraction. And I know that for a fraction, if I have 1 over x, I know that my x value cannot be 0. The reason is because a fraction cannot have a 0 in the denominator. And I will be using this fact to find my domain, my input value. So right here in this function, I have my input, my denominator as x plus 1. So I take this x plus 1 and I say it cannot equal 0. And I solve this equation and see what values I would, for x, that would make the denominator 0. So here I know that x cannot equal negative 1. So right here, to write my domain, without knowing how the function looks like, I know that my domain is the x-axis. So now here, the only value that I'm restricted to is negative 1. So I put negative 1 on a number line, and I know it's an open circle. And I know that my function is defined everywhere else except at negative 1. So writing my domain in interval notation, we start from the left-hand side of the number line. So it's from negative infinity, comma, negative 1, parentheses because my negative 1 is excluded, union -1, comma, infinity. So for my range in this function, notice that I am able to obtain a negative output if I input a negative number for my input. However, I can also obtain a positive output. However, the only restriction that you would see right here that it is impossible to obtain a 0 as your output. Because first of all, you can't have a 0 in the denominator. And second of all, your highest number in the numerator is just a 2. So no matter what your number on the denominator is, you're never going to obtain a 0 as your outcome. You can also look at it as testing the 0. So you can just put 0 for f of x, 2 over x plus 1. Multiplying by the denominator would get you 0 is equal to 2, which is not a true statement. So here I would say that my range is from negative infinity, comma, 0, union 0, comma, infinity. On this problem, it's saying a cell phone company uses the function below to determine the cost fee in dollars for G gigabytes of data transfer. So here we're given a function C of G. However, notice that C of G, the function, is defined in two functions. So C of G is equal to 25 when my G is between 0 and 2. And then C of G is equal to 25 plus 10 times G minus 2 if G is greater than or equal to 2. So here we're asked to find when you are using 1.5 gigabytes. So here 1.5 is my input. So notice right here for this function, my inputs, I have two domains where the function is defined differently on the graph, and that's what we call a piecewise function. So 1.5 right here is between 0 and 2. So here I would be using this function, the top function, because that's where my domain is defined. That's where 1.5 lies on the x-axis between 0 and 2. So now here, if I am using 1.5 gigabytes, then I would just say that my output, I would be paying $25. So that's for 1.5 gigabytes. However, if I used 4 gigabytes, now my 4 gigabytes is greater than 2. So here I would be using the second function because that's where my 4 is defined on when G is greater than or equal to 2. So now right here, I would take my other function, 25 plus 10, G minus 2. And to find how much I would be paying for, all I have to do is take that 4 and put it in for my G. So 25 plus 10, 4 minus 2. And now I solve 25 plus 10, 4 minus 2 is 2, 25 plus 20. I would be paying $45 if I used 4 gigabytes. So in this problem, we are given a function f of x, and we need to sketch a graph for it. So this function right here, notice that inside of this function, there's 3 functions. So this function is made out of 3 functions. So the first thing we need to know is that in order for us to graph it, we need to know the shape of each function. So my first one is f of x is equal to x squared. And we know that an x squared has a parabola shape. So that is for the first function. Now the second one is f of x is equal to 3. So I know that it's a line going through the y-axis at 3. And then my last one is the identity function, meaning that for every input, I am going to get exactly one output, and that output is going to be what my input value is. So if I input a 1, my output is going to be a 1. If I input a 2, my output is going to be a 2. So now after I know the shape of each graph, now I'm going to draw a number line, and I'm going to look at the domains that for each function. So notice that here I have a number line. Here the conditions they're given, we have the 1 value, we have the 1 and 2 on my second function, and we have the 2 on my third function. So looking at my first function, my 1, so I know that my 1 is my x values are less than 1 in the first function, meaning that my first function is identified when x is less than 1, less than or equal to 1. So my first function is going to have a closed dot, meaning that the 1 value is included in my first function, and it's going to be less than. So that is for my parabola shape. My domain is identified from -infinity up to 1. So now my second function, f of x is equal to 3, it's from 1 to my value 2. So I'm going to use a different color, blue. So I know that my function for my second function for f of x is equal to 3. I know that it starts at 1. However, it's an open circle because my 1 is not identified in this function. And it's all the values between 1 and 2. And my 2 value here, it's a closed circle because it is identified. It's less than or equal to 2. So now for my third function, it's when x values are greater than 2. So my third function is going to have an open circle at 2, and it's going to be identified throughout the values to the right. So after I know where my each function is identified, now I am going to draw my functions at a graph. Put in all these functions in one graph. So now here, I know my 1 value is identified in my first function. My parabola f of x is equal to 2. So I need to know that value exactly. So I am going to put my 1 value into my parabola. So f of 1 is equal to 1 squared is equal to 1. So I know that I have a point at 1 comma 1, and it is going to be right here. So that is the point that is identified, and it's going to have a parabola shape. So I know that my graph is going to look like this. So I have my first function graphed on the number line. Now I need to look into my second function. I know it's going to be from 1 to 2, and I know that any value I input for that function, the output is always going to be 3. So even if I input a 1, it's going to be 3. So right here, my function, I am going to have at 1, it's going to be an open circle. And then it's always going to have a linear line at 3. So y equals 3. So now this is my second function being graphed. Now for my identity function at 2. Now notice the 2 is already identified at f of x equals 3. So now here, my third function is when x is greater than 2. I know that when I input a 2 into here, even though it's not identified, I know that I'm going to have an open circle at 2. And now if I input a 3, I know I'm going to have a value at 3. So now graphing this function, it's going to look something like this.